Hello everybody. In this video we're going to talk about one thing that's kind of being used a lot by people who do experimental work and do simulations at the same time. So to understand what we are gonna do, we just gonna review quickly the very first steps we follow to build our model. So first we go to specifications and then define the components. And here in the methods, we go and pick the thermodynamic model. And here I'm just working with water and ethanol, and that's why I'm getting these, or using the NRTL model. And if you remember, sometimes we needed to or need to go to the binary interaction parameters and make sure that the software will automatically generate these values. And this was just kind of routine step that we used to do, and then we go forward and do the rest of the work. But I'm gonna stop here for just 1 or 2 minutes just to talk about what we have here. So these are parameters that are being used in the thermodynamic model, the NRTL model, and they represent the interactions between the components that we have in our system. So this is component I and component J. This is the binary interaction parameter A between methanol and water, and this is the interaction parameter A between water and ethanol. So it's not the same. Aij is not equal to Aji. And this is the second interaction parameter between methanol and water, the second between water and methanol. And this is C. It's just Ij. We don't have Cji, so C is only one value. It doesn't have Ij and Ji. So these values are automatically generated because the software has the built-in data bank that contains all these values, and this is what we see here, that the values retrieved from APv90 VLEIG. This is the name of the data bank that was used to get the values from. You can get them from any other data bank, but this is not the point now. So we use these interaction parameters and we do our simulations and everything is fine. But in some cases you would do some experiments in the lab and you get some equilibrium data like these data. So what we see here are just temperature composition data. You just went to the lab. You put methanol and water, and you measure the equilibrium compositions in the liquid and the vapor phases at different temperatures, and this is what we got. And I want to use this data to do my simulations instead of having or using the built-in data. So I want to generate the binary interaction parameters that represent my data, and either to use them in the simulation or to use them somewhere else, but just to generate these values. And to do this, we do what's called regression. Regression is kind of similar to data fitting, but it's kind of more general and more powerful way of doing this. And in this case, you have your model and you have the data, and you want to see what are the values of the parameters that would make your model very close to the experimental data. So we're gonna do this here in Aspen Plus, and it's pretty simple. But the main issue that will face, I think, the users who will do this is to be able to communicate properly with the software and know how to tell him what you want to tell him. And this is the point, I think, in my point of view. So let's go ahead and see what we need to do. So we have to do two things. The first is to define our data set or the experimental data. I want to tell the Aspen Plus, here is the data that you're going to use to do the regression. And the second point is to tell Aspen Plus that I want to do the regression to get these parameters. So I want to define the parameters that are going to go ahead and do the regression to generate. So the first part is here. You have here this data. It's just a place to put your data. So you're just creating a new set of data, and then You can either do it for a mixture or a pure component. In our case, we have a mixture, so I'm gonna go for a mixture and press OK. Here is gonna ask you what components we're interested in. I'm just interested in water and methanol. If you have more components in your system, then you can choose 2, 3, or 4 of them, whatever the number that you're interested in. This is about the type of data that you're going to provide. It is either phase equilibrium data, thermodynamic, transport, electrolyte, salt solubility, whatever. If you go to these for all, you'll find all the lists of or types of data type. I have here the phase equilibrium is just short list, and the data I have are Tx. These this is the temperature, and this is x, and this is y. So I'm just having txy diagram. This is at 1 atmosphere, which is 1.013 bars, and this is mole fraction. So this tab is fully defined now. Let's go to the second tab, which is the data. This is where I put the data I have. I'm gonna split the screen so that I can copy and paste easily, and it's way better to have them in a spreadsheet like this, so you can copy and paste the data without wasting time on typing the values. This is the X methanol, and this is the Y methanol. You'll find that the X water and Y water are automatically calculated because it's a binary system, so the sum should be 1. Here you'll find that the first row is standard deviation. I don't really understand why we have this here, but it's something that you cannot remove, and it's not gonna interfere with the results, so it's okay to keep it. If anybody knows why you have it here, please let me know. I'd be happy to know that. So now we're done with defining the data that we have, the experimental data. And now we need to go to the second part, which is which is the regression. You would expect that there's something here that's called regression, but you will not find anything like that. But if you take a look here, you'll find that we have here 3 run modes. Run mode of analysis, which we have been discussing in the previous videos about the plotting the pure component diagrams, binary phase diagrams, ternary phase diagrams, whatever the type of diagram that we are interested in. It's like this. And we have here the estimation, and in the estimation you have the software will generate the parameters that are missing, but in this case it's doing this based on the molecular structure, so it knows that the functional group of this shape would do this or will have this effect on the properties. So it's kind of estimation. And here we have the regression, which is the point of interest. And when we click on the regression tab, you'd see that, or a button, and see that there is a new folder that shows up here. It's called regression, and it's red, highlighted in red because we haven't defined anything. While we are in the regression mode, the run button will do the regression. So it's not like what we did before. You will find that like in the binary phase diagram, you'll find that there is a button here that tells you run the analysis, and it's gonna do the no it's gonna be done by pressing on the run button here. So what we need to define here is first I'm gonna call it DR1 as it says. It's the data regression 1. The method is an RTL. This is the data set that we defined already. It's already available here, so I choose it here. If it's not defined, then you have to go and define it and come back here so that you can find it in the datasets list here. And here comes the tricky part, and this is what we or where we define the parameters, A, B, C, and all these things. Again, just to be aware of what we're gonna do. The names that are or the titles that are put here are very deceiving. The name is misleading name. So I think it's one big challenge is to understand what the software means by these titles. So it said the type, which is either parameter for a pure component, it's a binary parameter, group parameter for unifag group, as it says here in the hint, and the unifag group binary parameter, or pair parameter for electrolyte in RTL, or chemistry. It's equilibrium constant for electrolyte chemistry. We're interested in a binary parameter now. And here comes the tricky part. Now it says name, and if you choose this, you'd find that these are the names of the parameters that you have, um, and you'd find that there are interaction parameter for quadratic mixing rule, for liquid viscosity models. There are like a bunch of things here. We are interested in the binary parameters of an RTL activity coefficient model, so this is fine. Now comes the element. The element, when I very first did this the first time, I was thinking of the element like the element in the periodic table. But just to understand what the software means by element, we will go to methods and back to the parameter, the binary interaction parameters, and here. This is the part that we were discussing in the beginning of this video. Just to understand what it means by element, this is an element. So Aij and Aji is element number 1. Bij and Bji is element number 2. Cij is element number 3. So I have two element, again, element 1 is present twice, element 2 is present twice, and element 3 is present once. So I have 5 elements that I want to do. Now let's go back to this here and go to the parameters. So I'm now interested in element number 1, which is A, between methanol and water. This means that it is Aij, and this is okay for him now. Now we'll go to the binary parameter, and then an RTL, and then element number 1, and then water and methanol, and this is AJI. I'm gonna repeat it again for. I don't understand why they don't call it A and B or whatever the name. Or put some helpful hints here. It took me a long time to figure out that this is what it means by, and even the hint here is not very helpful. It says element number for the parameter equals 1 for scalar parameter, element of vector parameter that are not regressed are fixed to the value of data bank. So it doesn't clearly tell that this is the parameter number. So anyway, so we have here two parameter number 2 available twice and parameter number 3 available once. This is methanol, water, methanol. This is water, methanol, water. So this is Aij, Aji, Bij, Bji, and then Cij. If you put Cji, it's gonna give you an error and tell you that this is a duplicate because Cij is equal to Cji. So this is all what I need to do. I can now go ahead and press the run button, and it's gonna ask me, is this what you're gonna or you wanna do? And of course, you can do more than or add more than one regression set. So you can do some of them and don't do the rest. So I have only one, so I'm gonna run. And if the run goes smoothly without any issues, you'd see this this window or this message. So it tells you that there are already values for the NRTL parameters for the mixture methanol and water in the parameter form. So already which we have already checked here, and we can replace these values with the values that I am generating by the regression model. So if you press yes to all, it's gonna replace the 5 parameters with the new 5 parameters that are calculated from the regression model. Of course, I don't want to do that because I don't want to mess with the data bank. So I'm gonna say no to all, and now we can take a look at the results. So it's available here. You can find that these are the components, the values of the components, which is in RTL1 AIJ, AJI, BIJ, BJI, and CIJ. So these are the 5 parameters. They are calculated. We can go ahead and see this residual because this residual is kind of represents the accuracy of the regression that's being done, or the percent error that's there. So it gives you the value of the experimental data and the value based on the model after regression. And the difference and the percent difference. You can do this for the pressure, you can do this for the mole fractions, for the compositions, whatever. So you can find the values here. They're not very high values, or just actually very low values. You can visualize it more by plotting the TXY diagram. You can see that these dots are the experimental data. The lines are the model, the estimation based on the model. And they kind of have kind of good agreement with the experimental data that we provided in the very beginning. So this is the what we have here. You can plot anything. You have all the values for the experimental and the model or after regression. Here are some more values for the now it's in the residuals. You can see in the deviation the root mean square errors, the average absolute percent of the errors, root mean square errors as value, not as percent, average deviation, maximum deviation. So all the values are kind of indications of the goodness of the regression that was done. So once you're done, you can go back and to the analysis environment. It's not gonna delete the regression data that you entered, so they're still here, and the results are still here as well. But they don't show up when you go to the analysis model for some reason that I don't understand. I think because it's not gonna work in the analysis mode, so it has to disappear so you don't mess up with anything. Anyway, so I hope this helps, and I'll see you in the next video, inshallah. Goodbye.